Good.
But the logic is really good, you see.
But the logic is really good, you see. 1% error already.
That's a serious improvement than yesterday.
That's a serious improvement than yesterday. How we got this low error? Because we have more data points today.
This is how we have to collect
This is how we have to collect as much as data for the deep learning or any kind of machine learning.
And I hope it will down to 0.9.
And I hope it will down to 0.9. Sorry.
It is a far less
It is far less than a
0.1%. Yes.
Yes.
My error is seriously low.
My error is seriously low.
My
That
learning
means
is almost
my learning is almost 100%.
99.999%.
99.999%.
Okay. So I knew everything.
So I knew everything what I studied.
This is the idea.
This is the idea.
Possibly it is
The spot here is still black, so it is still doing calculation.
See how
Let's see how better it can be.
Okay.
Okay.
I think it is doing.
I think it is doing all the calculations. All 500 equals are gone. Why it is not still busy, my goodness. What happened? Kevin looks again busy.
Anyway.
Okay. Anyway,
It looks finished.
but okay. Let me run this as well.
Now convert the
training into a data frame
and then plot it.
We will see how it looks like.
Definitely.
Looking this number, I am very encouraged. Unlike yesterday, it was like 3% or 4%. That was very discouraging part. But today I have more data points and my error is seriously low. And
this number is same for everyone.
which number?
The last two because 0.09 and the rest.
Yeah, I think it should be
So I think I get 0.08.
0.08. Maybe we should have some. Okay, I understand. We have two random state here. One is shuffling the data at the time, and another is at the time we train the data. Okay, I missed that part here. In the model training time, I am not putting random state. Okay, you can check with another example that you have yesterday. Okay, I don't like to explore that much. Let's go down. But anyhow, it is far better than yesterday's result. We all are convinced on this case. Okay, like 0.09% is a seriously low error. Then yesterday, okay, let me see the lowest value of error with this last line, lowest value 0.094 roughly. Okay, so this is how the white wine example is performed, and this strategy can be applied to any domain. Okay, right away you can work on a complete problem once this is performed. And let me show. Open one blank. Okay, let us work live together for the concrete. But at least I will initiate the idea and then I will leave and move to another problem. But you can continue on that part later on. Okay, at least I will show you how to move ahead. Open a new notebook, blank notebook. Okay, what you have to do is you have to at least copy this error. There is no doubt. This is same for concrete example as well. Okay, let me copy that error and paste it here. And now I would like to save. Right click on the untitled section here, right here, and rename the notebook. Okay, right click there and rename this notebook as concrete because we are on or cement. Let's say easy cement, and hit the enter. Because I am working on the cement now. Okay, although cement is part of concrete anyway, but the common word is cement. This we can say this floor is cement floor, then concrete floor sometimes. and you run this one, there will be no error, I am very sure. And go to the again white wine example and copy the second cell as well. But this time you have to change the file name that you are reading. Okay, copy this and paste here. This is exactly how you will, basically you are learning how to do machine learning. And this is the way computer also do. First we give them complete data and answer. Out of that it makes some prediction later on. So here also we are doing the same thing. I showed you how to work on white wine. And now from that all the workflow we understand that we are trying to work on the cement problem. Okay. And but this file will be changed. I hope the file name is concrete in the data folder. Let me verify that. Okay, just a minute. Go to data folder and check the names. Okay, there are so many data today, and this is your data. And if you think that you might mistake typing, then you copy paste. That is a 100% accurate method. There is no chance of error if you do copy on my things. But and this data is not separated with semicolon. So I may safely remove this safe value or write comma because I let us see that what is the separator on that value. Okay, the separator is comma. It is very obvious in this case. And while I open the file, let us read the column header as well. The first is amount of cement on that concrete, and blast furnace slag, second column, fly ash, water, super plasticizer, coarse aggregate, fine aggregate, is compressive strength. That is the last column we are going to predict. So how many columns are here? 1, 2, 3, 4, 5, 6, 7, 8, 9 columns. Out of 9 columns, the last column is target, and all other columns are features. Okay. So this idea is good enough for us to work with. Now I know the data file, and at least raw file I study, and I understand my. So separator, either you write comma or you can delete also. Okay, it is up to you. Let me run it. There is no error. That means I am reading my file correctly. And what we have to do after reading, we have to hit. Sorry, I don't like red wine here. I like concrete or logic as well, because this is we are working on the example of concrete. And if our data set data frame is white wine, then it doesn't look very relevant. Okay, it is technically correct, but not a relevant one. So I change my name of the and I will read again. My data frame name is now concrete, and I am reading the concrete file. But you can put any name. It is up to you, but try to put relevance. Establish some relevance. And then what we do is, and here you have to do some changes. Okay, you have to do some changes. So what I am doing is, instead of all the red wines will remove, right? Oh, sorry. I am also doing some copy paste badly. Here should be white wine, isn't it? I missed that part while doing copy paste and lack of time. I missed that part, and I will say sorry for this. Now all the red wine anyway, this is concrete, and make changes to it. So you are also able to do with me here as I am doing. and let us leave and random state also let it be 0. And index, now I am sure that I am reading my data frame correctly. First is cement, blast furnace like fly ash, water, super plasticizer, coarse aggregate, fine aggregate, air, and compressive strength is the last column, which is actually we are going to train on it. So until now, I am mostly 25% of the concrete problem is done. Just talking with you, I finished 25% of the coding. And next part is rescale your data frame from 0 to 1 and do this. Just here you don't need to do anything. You can just copy paste and if needed, change the data set. I think, yes, df train, okay, yeah, nothing I have to do here. Just copy paste. That cell can be changed, copy paste without any changes, and you have to run it. Now let's go to the next part. And here you are splitting the targets, okay, feature and target. And here I will slight modification on the, instead of quality, I will write compressive strength. Okay, that is what I have to change because I knew that on the that is different on the cement data set. Quality is replaced by this value. Copy this value. Copy, okay, do not type, do not worry to type. Copy is safe. Although blind copy is little boring, but white copy is good. Paste that so that there is no chance of spelling mistake. Paste. 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 So I am done. So after this, I have 824. Now sample size is not that big, okay? By the way, like in white wine case, but it is 8 times better than perovskite case yesterday. It's still 8 times good. Okay, now let's go to the next step. Orderly established criteria, you have to set it. And here you don't need to change a single word because there is no information about the problem specific information here. So you can just copy paste this without any change. No error, right? I told you there is no system specific information on this cell. Now go back to here and model. Model you have to change the input size only. All other remain same in the model as well. Input size is 8. Here it is 11. Okay, that we need to change while pasting. So I will change it here. Instead of 11, my data is 8. So I saved it and I will run. So there is no error. That means I am doing correct until here. And let's go back to the wine example and compile the code. And here is also there is no system specific information, so you can copy paste without any change. That is the good thing for this cell. No error. Now let's move to the next one. And here. Let me add one thing, okay? The seed. Because seed is missing here. Therefore, our results are slightly different. Let me check the yesterday's perovskite problem and then make it very same for all of us. Okay, I think this has been done differently. Okay, let us forget about this. This is done differently. Okay. Anyway, the error with this is very insignificant anyway. So let's go to the next cell, or we can run. I think we can run the training now. We are in the phase to run the training, so there is no other thing. And here I have to decrease the batch size. Batch size is, this one batch size is just overkill, unnecessary. Okay, because my data is less than 1000, so why should I take back on the power of 2? Okay, this is so nearest power of 2 is 1028. Sorry, 24. 1096 is totally not required. I am sure because my data is less than 1000. So let's run it now. So out of the white wine problem, we are able to run the concrete problem. That's a great learning, I believe. So in the same fashion, you can do any other calculations also of similar type. Okay. All you have to do is your whole effort is on the collecting data. Now you have already pre-written code. You can just change your input file and some few words in the code, and you can run any other problem. Like instead of this red wine or what, you can do apple. What is the main fruit in Himachal? Apple or grape? Apple, okay, yes. You can do the quality of apple by collecting many gradients. You plant that tree, okay, and there are what is the height of tree, circumference of tree, and what is the variety of that apple, particular apple, what is the color of the apple. There are many things that you can implement to particular the problem of Himachal Pradesh, or many other problems there are, not only this. So you can have ideas of that. Yeah, my training has been finished. Let me go down and see the loss. I am always interested to see the loss. Let me remove it first. Wow. 0.07% loss. Okay. Yesterday it was not so encouraging because the 4% almost was there for certain types. Now let's go and plot a calculation. And for plotting also you don't need to change anything. Just copy paste this block. Maybe I might have not copied the yes sign. Let me check here. Good. Now copy paste that and plot it. So here what I see is from the trend of this graph, trend, okay, if I go 600 step or 1000 step, my learning would be even better. That's what I noticed in this graph. Because it is not going flat, it is still downward trend can be seen on this plot. So there is a chance that it will be even better if we allow few more steps, hypothesis to go. Okay, you can play on that part later on. I will leave for you. And let's find the minimum error. What was the minimum error in this case? Yes. And this error is 0.098, almost 0.1, means 1% error. This error is on the yellow line, orange line, okay? And that is the validation error. Validation error, not the training error, but I am plotting the validation error. You see, minimum validation loss is here, other item. And balance, if you do, obviously you can plot another loss also. Let me change that in a new cell. What you do is minimum, change validation to train, and let's see what is just the loss, okay, not the, but here you can do that. Yeah. While training, it is doing very good, but while predicting, it has little bit more error, but it is acceptable range. So while sitting on this chair and you are working there, we are able to design totally new deep learning code from the example given. Okay, that's a good learning. That is how the machine learning also works. First, we have to give questions and answers. It will design some things, and later on we take the answer and we just ask the question, and it will try to predict the answer. So any problem so far? Let me come to your bench and see if you have done the complete problem correctly. But I will not punish you, okay? If you haven't done it correctly also.